Hello, I'm Dr. Douglas Fitzovich of the Pikeville College School of Osteopathic Medicine, and this is Section 10 of Physiology, Gastrointestinal Physiology. Now, GI physiology, even though it's a whole system, receives only a moderate amount of attention on the USMLE. So what I'm going to be attempting to do is to identify what, on a year-to-year average, is the high-yield material from this topic. You need to know the intrinsic properties of smooth muscle, the swallowing reflex, and motility in other regions of the GI tract. So your stomach, small intestine, and large intestine motility. Your salivary and gastric secretions. The hormonal regulation of pancreatic secretion. Composition and function of bile. How bile salts are recycled, your enterohepatic circulation. Digestion and absorption of carbohydrates, protein, and fats, lipids. Now, on this topic, your digestion and absorption, you may find it useful to review the biochemistry along with the physiology, and also then try to have at hand pathology, because many of the questions on this will be your absorption disorders, your malabsorption diseases, and you need to know the pathways, the enzymes, and the consequences of a problem with these enzymes. Your reabsorption of water and electrolytes. Your disorders of esophageal motility and colonic motility. So your malabsorption disorders that I've already referenced, being related to the digestion and the absorption steps of nutrients. So we're going to start with your basic control of nervous and endocrine system of your GI tract. It starts out pretty simple. Of the autonomic nervous system, the two divisions, the sympathetic and the parasympathetic, basically do much the opposite. Sympathetic nervous system releases norepinephrine. This generally decreases motility, decreases secretion in the GI tract, but causes constriction of sphincters. So it decreases motility, so propulsive movements, mixing movements are decreased. And it also blocks the movement from one segment to another by constriction of sphincters. Parasympathetics, classically release of acetylcholine, which causes increased motility and increased secretion. However, some parasympathetic neurons also release VIP, which causes relaxation, a decreased constriction of sphincters. So these two aspects of the parasympathetics help you mix it and propel it, and with relaxation or decreased constriction of sphincters, help you dump it as well. Then you have, linked to the parasympathetics, release of gastrin-releasing peptide, which acts on G cells to cause release of gastrin, which of course has multiple effects that I'll be discussing later. So for your endocrine control of the GI system, you need to know the basic hormones. Secretin, CCK, cholecystokinin, gastrin, and gastric inhibitory peptide. You need to know the source. The S cells that line the duodenum for secretin. CCK, also from the duodenum. Gastrin, the G cells, especially in the antrum of the stomach, but also in the duodenum. And gastric inhibitory peptide in the duodenum. You need to know the stimuli. Acid stimulates secretion of secretin. So when do you secrete acid? Well, normally, of course, when you are either anticipating a meal, you smell the good food, or when you're eating it, when stomach contents have been increased. So it inhibits. What does secretin do? It inhibits stomach motility and secretions. In other words, the stomach has responded, it secreted acid, and you don't need any more acid. You've got enough. So you have secretin. And in the pancreas, here's the secrete part of secretin. It stimulates fluid secretion and especially bicarbonate. What's the functional value of that? To prevent excess acid in the duodenum and the rest of the small intestine. So when you produced a lot of acid, it's entered the duodenum, you have secretin released. The release of secretin causes release of bicarbonate, which buffers the acid so that you don't eat away the duodenum. So if you have an inability by the pancreas to produce secretin, you could expect a high risk of duodenal ulcers. Now let's look at CCK. CCK also secreted by the duodenum. When fat and amino acids from the partial digestion in the stomach enter the duodenum, you get release of CCK. It inhibits emptying of the stomach. Once again, this makes perfect sense. If you've just dumped something from the stomach into the duodenum, you need time to allow the duodenum to handle it. So you secrete CCK and you stop the emptying of the stomach. You put it on hold for a little while. It also stimulates pancreatic enzyme secretion, which will aid in the digestion and therefore the reabsorption of these substances. For the gallbladder, it causes contraction of the gallbladder and relaxation of the sphincter of Oddi, and therefore it helps you dump bile into the small intestine, again to assist with digestion and absorption of nutrients. For bile, of course, we're dealing with fats. Now on to gastrin. Gastrin, secreted by G cells of the stomach, especially in the antrum and the duodenum. When you stretch the stomach, when there's increased parasympathetic activity through gastrin-releasing peptide, when there are peptides in the stomach contents, you get increased secretion of gastrin. Note there's a negative feedback here. Because gastrin causes increased secretion of acid, when acid goes up in the stomach, it tends to shut off gastrin, so you limit how acidic the contents become. Then we have gastric inhibiting peptide, also produced in the duodenum, as so many other regulatory substances are. Fat, carbohydrates, and amino acids entering the duodenum cause increased secretion of GIP, which does what its name says. It inhibits the stomach. So once again, you don't have as much churning of the stomach contents and you don't have as much emptying. Note, an interesting point that connects over to endocrinology is that all four hormones stimulate release of insulin. Now, the important point about that is it's the reason you give an oral glucose tolerance test to a suspected diabetic or somebody who is suspected of hypoglycemia, because that's the way people take in their food. When you give an oral glucose load, you have a higher response of insulin than if you gave the same amount of glucose intravenously. So that's a little connection point over to your endocrine pancreas regulation.